kind of go into another part, which is another thing about Bash is that you can write little scripts, little coding scripts that will sort of automate these runs, right? That will change each of these numbers for us so we don't have to do it manually, and we'll run these one after the other. So, there is a script now available on the virtual machine called run bowtie2 sammp, because it's going to run our combined bowtie2 commands, our mapping command, and our samtools sort and samtools mpilup commands that will generate our snip calls. So let's first just take a look at this script. So I'm going to do that by first using this which command, which will tell me where this script is on the virtual machine. I can copy this to then print out what the script looks like. So I'm going to go through the script a little bit, just showing, kind of describing what the lines are doing in the script, and then I'll show you how to run it so that all of these run at the same time, and you can just do one command and walk away. So I'm actually gonna open this in Nano just because it'll be easier to see the coloring there. So this is what a Bash script looks like. Bash scripts can look like a lot of different things, but this is an example of one. And shout out to Dongju in our class for collaborating with ChatGPT to generate this script, because that's one thing that ChatGPT can be really useful for, is asking things like, Bash scripts. I find that oftentimes in like kind of harder coding things, or not even that harder coding things, it's often wrong, and sometimes you have to play with it a little bit, but it's a good application for it. So this script largely comes from ChatGPT and Dongju, so thank you for that. So let's talk about what the script is. The top line is what's called a shebang. This you'll see in most scripts of any different language, so Python or Perl or R. This line tells the computer system what language to interpret the rest of this code with, right? So languages are interpreters for the computer to work through. And because this script is in the language Bash, this is why Bash is here. Ben is here just because usually the program files, the language program files, are in a binary directory location called bin. And this is just a specific notation for the shebang. So if this was a Python script, this instead would say, Python 3. So going through the rest of the script, first we're defining some variables. So variables are like, basically stand-in characters to represent real data or many pieces of real data, and that's part of what makes them so useful. So these are hard-coded variables where the variable is going to something specific. So this is a specific phrase that this is being coded as. This, on the other hand, you'll see it fills in it using this other variable. So whatever is in the reference, which is what's in quotes here, is also what gets filled in here. So this is why it's defining the FASTA file, because it's this, our index name, plus the .fna for the FASTA file. And finally, it defines the name of our log output file so that it can just plug it in here as a variable. So the next part of this script opens up what's called a loop. So a loop is something where it's iterating over, one after the other until it reaches the end of whatever you ask it to do. So in this case, the range that we're asking it to cover is for I in this variable seek 440 through 448. So the way that this works is I is our numerical variable. I can be anything, right? Say you could say 4 read files in, all these FASTQ files. That would work too. But this is going to be a numerical variable because for I in this range, this is sequence from 440 to 448, and you see that plugged in right here. So this I variable iterates from 440 to 448, and that covers our accession number IDs, right? So you have to make this line, how you're setting up the loop, the iteration, very specific to, or very general, for what you're specifically trying to loop over. And in this case, we're trying to loop over our read files because each run we need a unique input, forward read file, input reverse read file, and output read file. Those all get plugged into our bow tie command, which it looks, similar to what we had been doing on the command line. So it plugs in this I variable that iterates from 440 to 448 to find this file name. And it saves that file name as input 1 and input 2. So for sequence, ERR 40, it fills that in 40, and then it finds this file. And so again, if your FASTP files or your trimmed files are in a different location, you will have to change this path, this address, to be more specific to where your exact files are, right? Because we always need to tell the command line exactly where to look for different files and directories. So you may have to change this as well. So these get plugged in, and then the output file also uses this I variable right here because it names our output file with the SRA accession number. So it'll just keep filling those in for each of these runs. So this is a loop, right? For each of these sequence, identifier IDs, it saves the forward reads, the reverse reads, and an output file as these variables. And then these variables, like I said, are placeholders. So they get plugged into this equation, which runs our whole command. So bowtie x, instead of the file name itself, it becomes this reference variable. And all of this is just the specific, bash syntax. Syntax is like the way the languages, use characters and the way they want things to be phrased and structured. So our reference file gets plugged in with this. This would be useful, right? If you had multiple references, you could iterate over all multiple ones with a variable. But ours is just a single one. So it sort of works just as well to also put it in here. But for the input 1, input 2, and the outputs, those are all changing every time we have a new read file. And so that use of variables is really nice. So for each of these runs, for each of these numbers in this range, it plugs in those numbers, finds these files, and sticks those file names as input into this command. And this is exactly kind of the structure that we were running on the command line, but just with these variables. So the way to then run this command is to, you can actually just call it from wherever you are. So scripts normally, if they're written, they have to be edited to be executable and to be, the command line has to know where to find those scripts to run them. So you have to put them in the path. That's sort of behind the curtain here. And if anyone wants to know more about that, I'm happy to talk more about it. But for our purposes, we can just run this script from the command line like this. As long as your, FP trimmed files are in the right places that match this script, that'll work. And if that's not the case for you, you can make a copy of this file and edit it yourself, actually. So if you wanted to make a copy of it, you could do which run bowtie. That will give you this location. And then to copy, you do copy the thing you want to copy, make a copy of, and then the location you want to copy it in. So here, that's / because I'm trying to copy it in my current location. So that way that you could have your own private copy to run. And if you have your own private copy to run in the command line, you'll need to add probably a / here to tell it to run the version that's in your current directory and not the version that's linked to the overall computer that everybody can run. So if you make edits in this file, if you make a copy of this file and then make edits of it, make sure to run / before it to tell it to run the current directory version and not the class-wide version, which you can run just by running the command itself. So I can hit this, I can run the command itself, but it's just going to run there, and then if the computer disconnects, it would, stop the processes. So I actually don't want to just run this by itself. I want to run it with no hup, what we just learned. So I'm going to stop this command using Control-C. And Control-C is different than Control-Z because Control-C is a hard close. It quits a process. You cannot restart it. So I'm going to add no hup to this command here. And When I run NoHup with it, it will run in the background. All those runs, one after the other, each read set will run without me having to stay connected to the server. And I'm also going to add the ampersand here to ask it to run it in the background so that I can check on the NoHup file, see how things are running. So before I run this, I'm going to delete any NoHup file that's there. Oh, there's not one. Okay, so I'm just going to run this, and it's going to create a NoHup file when this starts outputting, and this should run. If you're when you're first sort of troubleshooting it, you should run it without the ampersand to just see that it runs. And then you can use Control-Z and the BG command to run it in the background. Because if you just run it with the ampersand, if it quits, if it goes wrong, it may not tell you. So I can just run it without the ampersand for now. And it's going to leave me hanging here, so I'm going to do Control-Z to pause the command, and then I'm going to do BG to run it in the background. And this is just like if I had run it with the ampersand to begin with. So that is a very quick tutorial on job controls and running automated scripts. I definitely encourage everyone to mess around with it. Pretty much, if you're doing bioinformatics at scale, more than sort of, 10 entries or so, like y'all are experiencing, you may want to start automating things. So this is a useful thing to know. So thanks for watching all the way to the end, if you did, and I hope you learned something.